everyone, welcome back to another Pre-Calculus 12 video. Today we are doing the second half of 3.2, Equations of Polynomial Functions. And last day, when we did the first half of 3.2, or in the last video I should say, it was on graphing polynomial functions. So it's nice that you got to visually see what they look like. And then today we'll put the focus and emphasis on the algebra and the equations so that you can start to get a big picture view of how this all fits together. So let's get started with this first example where we have a polynomial that has -1, -1, 0, and 2 as its roots. And we know that p of 1 is equal to 5. What is the equation of the polynomial? So it's almost like this time we're working backwards. Last day we took the equation and we found the roots from it, and today we've been given the roots and we're working backwards to find the equation. Okay, so the nice thing about that is that we sort of already have some background knowledge as to how to go about this. And so let's get started with just writing the general form of the polynomial equation for what it potentially could be. So p of x is our way of writing it in function notation. And if I take a look at what we have to work with here, these roots that we were given, well, actually, before I get to that, there's something really important that I want to mention. When we are writing the equation, I want to make sure that I put an a or some variable at the front to account for the lead coefficient. Remember that the lead coefficient is what tells us if it's right side up or flipped upside down, like reflected in the x-axis. So always put a variable there, sort of as a placeholder to figure out how the equation is going to start and if there's a reflection there or not. So there's the first part, and then going through it, I'd kind of like to go in order. Notice that there's a 0 there. That would mean that we must have an x here in order for that to be a root of 0. And then if I have a 2 here, I would say that that would show up as a x minus 2. And then the reason I've chosen to save these for the end is because I know that if that's the root, I always do the opposite of what I see. So if I see -1, that's actually going to be +1. And because it's listed twice, I know that that has a multiplicity of 2. So you're starting to see how this ties in exactly with what we did in the last video. And so we sort of have a general idea of what this is going to look like. But in order to actually give my equation of the polynomial, I need to figure out what my a value is. So right now I don't know what it is, but you will always be given some information in some way, shape, or form that will allow you to plug in the values and figure out the a value or figure out what you're missing. So notice that we also were told this part, that p1 is equal to 5. So we can use that to help work our way through this. And so this actually just becomes sort of like a review of things we've done in the past that just has to do with substitution. So if p1 is equal to 5, that's ultimately telling me that my y value is equal to 5 when I plug in 1 for x. So rewriting this, I'm going to have a, and then my x value is actually going to be 1. The hardest part is color coding this all. And then here I'm going to have my 1 minus 2, and here I'm going to have 1 plus 1 squared. So basically, I just took this information that was given to me, that p1 equals 5, and I've just plugged it directly into the equation because take a look at the equation now. We notice that the only variable that's remaining is the a value, which lets us know that we can start to clean things up and isolate the a to figure out what the value is going to be. So I'll just leave this for now. And then working our way through this, when we multiply this all out and clean this up, which I know that you know how to do, that's just going to be 2 squared. That's just going to be -1. And when we multiply it all out, we get -4a. So go ahead and actually do that on your own to make sure that you are okay with that, but I know that you are by now. So the next step, if we want to get a by itself, is, again, you don't have to write out every single little step, but I'm going to do it in the video so that you can clearly see where things are coming from. We would ultimately do it, well, you've heard me say this since grade 9. Algebra is all about opposites, so the opposite would be dividing by -4. So we actually get -5/4 is our a value. And I'm going to just write it beside here to ensure that we do have enough room and you're able to see everything. But basically, to give my answer, I would say p of x equals, and instead of just leaving it as a, I plug in the value we just found, which is -5/4, and then that's going to be x times x minus 2 times x plus 1 squared. And that's going to be our equation or our solution for that one. So you can see how it quite nicely fits in with what we just finished doing in the last video. So in the last video, we learned how to graph something like this. Well, I think maybe in the last video we didn't have an a value there, but let's just quickly talk our way through that. To have this a value here, this is actually the same thing as what we did in the chapter on transformations, and this -5/4 would indicate a stretch, and this negative indicates that that's affecting all of the y values, so that's going to be a reflection in the x-axis. So it tells you that this polynomial would be flipped upside down. It's not asking us to do that. I just thought it would be helpful to build in some review and tie it into what we've already done in the last chapter instead of viewing it as a bunch of separate things that we do. Okay, so moving on, write an equation of a polynomial in lowest degree that represents the given example. So this is a similar thing that's going on, but the information's given to you in a different form. So instead of being given the roots and a p of 1 equals 5 and all of that, you're given a graph that you're able to look at, analyze, and pick out the things that you need in order to be able to come up with an equation. So let's take a look at this graph. It says, notice how it says in lowest degree. So I will talk a little bit more about that because I'll get to that in a second. But the fact that this says lowest degree is sort of a helpful hint for what we should do with this. Okay, so taking a look at this, let's start to pick out some helpful information. So the first thing I'm going to start with is, if we know a point, that's going to help us. So there's a few points that we can see there, but we can see 0, 2 is the y-intercept. So just at this point here. So 0, 2, I'm going to maybe use that, or that might come in handy. So I'm going to write that down. And then my zeros, or remember that they're called X-intercepts or roots, and all of those things mean the same thing. But we have zeros at -2, so that's right there. So -2. And then I have down here, it's bouncing off of the axis. So I know that it has a double root at 2. So just so I can keep track of things, I'm going to write it twice. That's just my way of making sure I don't forget something. Or you could just write 2 and put multiplicity of 2 or times 2, or find your method of what works for you. But I like to do this because then I know that I'm not missing out on anything and I'm less likely to forget. Okay, so now that we have this is actually looking a lot like the example we just did. So we can take a similar approach. We can start to write out our polynomial. So p of x equals a. Again, get into the habit of always putting that there. This is a common mistake that students make. They forget to put that there. And then let's start to write this out. If I have a -2, that must mean that it's x plus 2. And if I have a double root at 2, it's actually going to show up in the form of -2, and I'm going to square that. Okay, so it's looking a lot like the last example. In order to get this a value, I can use any information. I could have used any other point off of here that's clearly at a precise, accurate place. But the y-intercept is a nice, easy one to use. Always go with the easiest thing that you see in front of you. Because that's ultimately what math is. We're using patterns to try to simplify things and make it easier. So if the point is 0, 2, I'm going to plug in a 2 for the y value. The a stays there, and the 0 goes in for x. And I mean, again, you definitely don't have to do this and plug it all in and write it out. I know that you all know how to do this, but I want to make sure that you very clearly can see where everything is coming from. So that's where this stuff is coming from. Okay, so then working our way through this is nice and easy. Those are just wiped out. And so you can see that 2 is just equal to 8a, because that's just going to end up getting squared. So 4 times 2, so this makes sense. And then if we want just a by itself, we're going to do 2 divided by 8, which was simplified to 1/4. After all of that, our solution is going to be p of x equals 1/4. So I just simply fill in my a value, and I can leave everything else as is. So x plus 2 and x minus 2 all squared, and there's our solution. Not solution, I guess there's our equation, which is what it was asking for. And this is a good habit to get into. Always go back to the question, because after you've spent time working your way through this, you'd be shocked at how many people hand in tests or quizzes or assignments where they didn't even answer the question. So go back and reread it and check to see that you did actually do what it was asking for. And it definitely is. Now let's talk about this lowest degree part. Notice here, if I go back to the graph, there's 1, 2, 3 changes of direction. That could indicate an x to the 3 equation. That's the degree in lowest form, but it could also be x to the 5 or x to the 7, or all of those things we talked about in the last video. So the fact that it tells me lowest degree, I can make the assumption that it's only going to be x to the 3, which is what we've done here, because we have this squared here, and then we have another x here, which indicates that when we multiply this all out, we would end up with an x to the 3 as our lead term. So it would be a cubic, which is what this is. Okay, moving on to the next one, which, believe it or not, is the same thing, but it's taking on a slightly different form. And what I want you to do right now is to read through this and then pause your video and try this on your own. I know that we haven't done one exactly like this, but you have all of the information that you need to be able to interpret and make sense of this. So I think it would be helpful if you try this on your own, and I'll run through the solution. When you're ready for it, you can unpause it or play it again and have a look. So it says, sketch the graph of a polynomial function of lowest degree, so just like in the last one, given the sign diagram. So that's what this thing is called. It's a sign diagram that basically is giving you information, just like in the last couple of examples, but it's presented to you in a slightly different form. So let's interpret this and make sense of it. So we notice that the value of f of x is basically, so this stuff up here is basically telling you what the y values are doing. So it's telling you that, I'm going to get rid of that, right here and right here, the y values are above the x-axis. And right here, and right here, the y values are below the x-axis. So if the y values are positive, it's above the x-axis. If the y values are negative, like the arrows, it would be below the x-axis. So if we think about this, in order for that to occur, well, let's sort of zoom in on this portion. In order for the y values to go from positive to negative here, it must have crossed. It must have crossed at -3. So like right here, if it tells us what the zeros are, so if the zero's at -3 and it went from positive to negative, this must have a cross here. And the reason I know it's a cross and not a slide, because both of those could make the values go from positive to negative, I choose the cross because it says here to pick the lowest degree. And a cross is less than a slide, because remember that a slide happens when we have multiplicity of 3. So that helps us to figure out what's happening here. Maybe to get an idea of what's happening, we can write this down here to sort of keep track of things and to be organized. And then we notice that, you know what, actually, I'm sort of talking and thinking out loud as we do this. Maybe it's helpful if we also kind of draw this. So if it's at -3, and my y value started at positive, I know that this must have happened. So I'm just going to do that to sort of, and I would encourage you to do this too. If you can visually draw it and start to get a sense of what it looks like, that's probably going to help you out here. And then notice what happens. The next 0 is at the number 0. So right here, I'm going to put dots at the zeros or the roots. And it goes from negative at -3. So from down here, it comes up to the 0, but then it goes back to a 0 here. I'm going to get rid of, sorry, not back to 0. I'm sorry, I'm not making sense. It goes back to a negative y value. So it had a negative y value here after it crossed through the -3, 0 or the root, and then it ends up again at a negative value. So how could we have a root here and then for it to end up at a negative y value again? That means it must have bounced off of here. It had to have bounced off of here. There's no other way that that could happen. So maybe I put an x here. That bothers me. I want to do it ahead. So x squared must happen there. So we're just sort of thinking our way through and organizing the information. I mean, it's not a big deal if you wrote it after x plus 3, but it's just, I just like to have the x at the start on its own. Okay, so then we have another root at the number 2 that I'm just going to put there. I'm going to put a dot there. And it goes from these negative y values we looked at here. Now I'm putting the pink arrow there. And then after 2, it goes to a positive y value. So if we have a positive y value there, then it must have come to the 2 from down here, and it must cross. So I'm going to assume again that's a cross. I should write here that that's a bounce. Again, I'm assuming it's a cross because it told me to find the lowest degree. So technically this could be a slide, but I'm going to shoot for the bare minimum and say that it's just a cross. And then notice that at the next root, or at the next 0, that happens at a value of 3, it goes from positive back down to negative here for my y values. So that indicates that it must, whoops, I should draw that as a smooth curve. That indicates that it must have crossed back down again. So what tells me where to go with this, or the pattern of behavior, is looking at the y values of whether they're positive or negative, or it's, so basically this is kind of just like an organizational thing. So this is just my sketch. Oh, it actually did ask for the sketch. See what I mean? That I thought that we were trying to come up with the equation, but it's just asking for a sketch of it. So this actually would be our solution to have it. I guess I can get rid of this then. We just want the sketch. So this would be an acceptable way to show the sketch. As far as these local minimum and local maximum, we don't really technically know where those would be, how high up it would go or how low, but that's okay. If it's a sketch, we're just showing the basic information that we are able to get from the sign diagram. So I hope that that is helpful, and let's move on to the next one. Ooh, okay, so again, I want you to pause the video and try this on your own. Okay, so take a look at what it's telling us about this information. A is less than B, and they're both less than 0. So I'm going to start by writing negative A and negative B. And although we never write it, I'm going to put positive C. So this is just how my mind works and how I like to go through and organize the information. We want to sketch this graph out, and this information where A is less than B, blah, 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 that's given to us to help us to determine where these things go. Because I know that on here it says X minus A and X minus B and X minus C, but this, where A is less than B, etc., is telling us what to plug into these values. So I'm also going to write, this is a quartic function. I know that because I have the two x's here, so that would be x squared. There's another x, so that would be x cubed, and x to the 4 because of the x over here. So I know that it's a quartic, and I'm going to use this information here to figure out what to plug into here. So if I'm plugging in x minus, I'm plugging in a minus a. I hope that that makes sense to everybody. So that's like the information that I got down here where I'm putting the big star. So, and then the next one, same thing, x minus, and it's actually technically minus b, and that whole thing is squared. And then the other one is just exactly as we see it, which is x minus c. So to clean this up, we actually get minus minus a is going to be plus a. That's going to be x plus b squared, and that's going to be x minus c. So this is a little bit tricky. It's a matter of, again, organization and keeping things clear. So I would suggest looking at these values to plug in to determine how this is going to go. Notice how there's no lead coefficient here. If there's nothing written there, we just assume it's a positive 1. So we can look at that and say, let's state our end behavior. So it starts up in quadrant 2. We know this because it's a quartic, which is a W. So it could look like a W, or flipped upside down could be an M. But since there's no negative in front of here, we know that it's a W. So it starts up in 2 and it ends up in 1, like a W. And we know that there's a bounce at B. So I'm not technically going to be able to come up with a graph with precise, accurate numbers because we don't know what A, B, and C are, but we do know the relationship between them. We know where they are relative to one another, so that's what we're using to determine where this information goes. I know that A is less than B, and I know that they're both negative, so I'm just going to mark it over here, and I'm going to mark B over here, and it really doesn't matter where I put them. And then I'm going to put the dots there because these indicate the roots or the zeros that we mentioned. And then I know that there's a bounce at B. So I can sort of think my way through this. It starts up here. I don't know how low it goes, but I'm just going to sort of estimate, go down to there, and that's what my graph's going to look like. I only ended the arrow there because it's going to run into my writing. So that's how this is going to look. Okay, so I've given you some variety for how these questions can show up. They are all testing or looking at similar concepts or ideas. I think it's good to get a variety of different methods, and that's what really helps you to see if you've understood the concepts or not. Moving on, find all of the values of x such that f of x is greater than or equal to 0. Okay, so you've kind of seen things like this in the past, but not quite in this form. So let's think our way through this. Oh, I see. This is for E and F, I believe, from your homework. So I think maybe people have asked for this. So I thought it would be helpful for us to go through it together, and then you'll have other questions like this in number 4 that are similar, but it's helpful if we go through 1 or 2 of them together. So find all the values of x such that f of x is greater than or equal to 0. I didn't write this in the best form. The f of x should be on the left, but that's okay. I think you get the idea by looking at it. Well, it's bothering me. Let's do it. F of x equals x to the 4 minus 4x squared. So that's what we're working with. And this is telling us that this whole thing needs to be greater than or equal to 0. So, to start with, let's factor this out. So notice how both of them have an x squared that we can factor out. So x squared, if I take that out, I'm left with x squared minus 4, and that all has to be greater than or equal to 0. Okay, so that's helping us sort of to figure out what's happening. X squared, and then notice that this is a difference of squares. So by now you're probably picking up on the fact that we're kind of doing the same things over and over again. Like you've been practicing factoring for years. So this is just us factoring, and now you're starting to see things coming together, and you're realizing or learning why you learned factoring. So you've been learning individual little skills, and now we get to put it all together, and you see why you learn those skills, because we wouldn't be able to solve things like this without that. X plus 2, x minus 2, and we want the whole thing to be greater than or equal to 0. Okay, well, I'm going to continue up here, and in order to really make sense of this, or to get some clarity, I like to graph things out. It's just a quick sketch, but it'll help you to get an idea of what's happening. So there's my root at x squared, or 0, so I know there's going to be a bounce there. And then I have one at 2 and one at negative 2. So I'm going to put some dots there to show that their roots are zeros. And so if I were to sketch this out, we'll take a look at the original equation here. There's no negative in the lead term, so I know that it's a positive. It's also a quartic because of this x to the 4. So it's going to make a W shape. So I know that it's going to start there. It must bounce from 0 back down and come up like this, because I know it's got to be a W because of the positive lead term. Okay, so then in order to make sense of this, I'm looking for where it's greater than or equal to 0. Well, that's happening here. It's equal to 0 here, and it's also happening here. So in order to get our solution for this, I want to talk about or list off, well, let me do this. Solution, that's my little abbreviation for solution if you haven't seen it yet. And I like to go from left to right because that's how we, well, smallest to largest, that's how we read. It's just a nice organizational thing. So starting from this portion here, where are my y values greater than or equal to 0, which is what this question's asking? Well, I would say when x is less than or equal to negative 2. So that accounts for this part. Then I get to this part where it is equal to 0. So I would say at x equals 0 to account for that little blue portion. And then over here, I would say this also happens when x is greater than or equal to 2. So I know that this looks different than the other stuff that we've been doing, but basically this is just us communicating where the y values would be greater than or equal to 0. And really pay attention to the nitpicky little details with that. Sometimes it might just say greater than 0 and not equal to, so you've got to really be nitpicky. If that were the case, I'd take off the little equal signs at the bottom, but that's not the case, so we leave them there because it can be equal to negative 2 as well. Okay, so just really quickly, because I think that this is pretty much the same thing, this is also a part of the same question. So we want to know all of the x values such that f of x is greater than or equal to 0. So we can start by factoring this out as well, just like the other one was. So we can pull out an x, and then we have 9 minus x squared. and we want that to be greater than or equal to 0. So notice the pattern. We're doing exactly the same thing as in the last question. And then notice how, well, you know what, actually, I'm going to take this factoring a step further. I just like to, you don't have to do this, but I just feel it makes it easier. I don't like that it's 9 minus x squared. So let's factor out the negative. So let's make it negative x, and let's swap these. So it would actually be x squared minus 9 when I factor out the negative. Would have been smarter if we just did that all in one step, but that's okay. I've broken it down to 2 steps. And then we can see again we have a difference of squares. X plus 3, x minus 3, greater than or equal to 0. So you're probably now noticing that we're kind of just doing the same thing over and over again. There's a root at 0. There, I would have another one at 3. So I'm going to mark a circle there. And one at negative 3. So I'm going to mark a circle there. So that accounts for all my roots. But notice that this time I do have a negative lead coefficient. This is clearly a cubic function, which I can tell from the exponent up there. Let's get rid of the last example. So it's clearly a cubic, so I know that it would either look like this or that it would look like this. And how I determine that is by looking at this lead coefficient. So since it's negative, I know that it's a flipped upside down cubic, which means I'm going to start facing up in quadrant 2 and I'm going to finish down in quadrant 4. And if I look here, there's no multiplicity of 2 or 3 or anything, so I'm just crossing through at each of these points. And so that, oh, I missed the last one, but that's basically what it would end up looking like. And then it's asking me where these values are greater than or equal to 0. So again, there it's greater than or equal to 0. Here it's greater than or equal to 0. And that's about it. So how do I actually give this solution as an answer? So solution would be when x is less than or equal to negative 3. And here it's in between 0 and 3. So x is greater than or equal to 0, less than or equal to 3. And that would be my answer for that one. Okay, so that is the end of the second half of 3.2. I hope that after going through the graphing and now the equations and putting it all together, you have a deeper understanding of how it all works. Again, this is the suggested assignment, page 127, 2 to 5, and 7. But of course, it's up to you if you want to do more questions for extra practice. That's always helpful. And that's it.